You've touched on the two key procedures in the ASHRAE ventilation and indoor air quality standard. This is ASHRAE standard 62.1. Most commercial buildings fall under ASHRAE standard 62.1. And in ASHRAE standard 62.1, there are two different ways designers, engineers, can determine how much outside air they will need to maintain indoor air quality. And that's really the purpose of that whole standard, is to ensure we have enough ventilation, air cleaning to assure healthy indoor environments. So you've got the ventilation rate procedure, the VRP, and the IAQ procedure, the IAQP. Both have been in the standard since the 80s, so they're not new. Mm-hmm. However, most buildings, most designers use the ventilation rate procedure because it's a very simple prescriptive approach. Essentially, you determine how much outside air you need to maintain air quality as a function of the type of building we're designing, the size of the building, the area we're designing, and the occupancy, the number of people we're designing the building to accommodate. And there's some simple math you can do accounting for those three different variables, and you get, I need so much outside air to maintain indoor air quality per the ASHRAE standard. And that's fine, that works well, that's what people have been doing for a long time. But as I said before, the challenge is that just relying on outside air ventilation to maintain indoor air quality, especially in extreme climates with rising energy costs, with more focus on climate change, is a challenge. And it's actually made even more challenging when you are in situations where you're dealing with wildfires, or you have a school maybe, or a building constructed near an industrial center or an inner city where you've got polluted outdoor air. In those cases, relying on outside air to deliver clean indoor air, when the outside air is not fresh, as we often refer to it, that can also create complications. So the other approach that ASHRAE has had in the standard since the 80s is called the indoor air quality procedure, and it's a performance-based approach. It basically says, we don't care how you achieve good indoor air quality, but as long as you can demonstrate you're delivering good indoor air quality, you're good as far as the code is concerned, the standard is concerned. And so what the IAQ procedure allows you to do that's different from the ventilation rate procedure is utilize air cleaning, technologies like ours, to directly control the contaminants that are generated by our buildings through this filtration technology we've developed. And if we can demonstrate that we're achieving the same air quality as if we were just relying on outside air, but do it more energy efficiently, do it more cost effective, that becomes very attractive. So the benefit of the IAQ procedure, it's a performance-based approach. It's all about, can we show we're delivering the same air quality, and then it doesn't matter how we get there. The challenge has been, it asked a lot of engineers to make decisions about, well, which contaminants for this school I'm working on should I be worried about, and what are the appropriate levels? And how do I know if the system's really working? And these are things that require expertise that many engineers probably don't have. And so for these reasons, the IAQP has not been widely adopted. But in the last 24 months, ASHRAE has recognized these deficiencies in the IAQ procedure and has introduced 3 key addendums or updates to the IAQ procedure that have made it much more prescriptive, like the ventilation rate procedure, much simpler for engineers to apply. But as I said before, one of the big challenges with the IAQ procedure for engineers was that they had to come up with a list of contaminants and the limits. One of the first updates ASHRAE made in February of 2022 was an addendum AA, it was called, to the 2019 version of standard 62.1 that essentially gave us the list. It said, okay, engineer, don't worry about it anymore. Here's the list, and here are the design limits. That's a huge help to the industry, to engineers who are worried about picking the right contaminants and the right limits. So that's a big deal. Later in 2022, ASHRAE published addendum N to the 2022 version of 62.1, and addendum N did something also very helpful. It essentially said, for all these cool air clean technologies that are out in the marketplace, how do we know how efficient they really are? So we know how effective they are at mitigating those contaminants that we're now worried about on that list. So addendum N gave us standard test procedures that all the air cleaning companies need to follow to basically demonstrate how efficient they are against that list of contaminants. So it adds rigor, it adds legitimacy, if you will, to this approach, because it basically says we have to have standard ways to understand, like for like, how effective these different technologies are, and we appreciate that. It creates more transparency, it creates more legitimacy for this approach. And then the final and perhaps most significant update was just published in October of 2023, and with this update, addendum C to the 2022 version, again, of 60.1, ASHRAE has published a calculator, an Excel-based calculator, to basically do all the math for the designer in a very simple way. So you can take the same inputs you might have used for the ventilation rate procedure, plug them in the calculator that ASHRAE is now providing, and it will do the calculations according to the IAQ procedure once you add in the efficiencies that you've used those standard tests to determine into the sheet. So we have a list of contaminants, we have design limits, we have how do we know how good the air cleaning solutions are, and we've got the calculator that makes applying it super simple. So we think these updates are going to make a huge difference in terms of getting engineers excited about applying the IAQ procedure to deliver all these benefits we talked about for owners, and just optimizing HVAC system design as a whole.